balancing of equations involving redox reactions. There are two different methods. Today we are going to see how we can balance equations using ion electron method or half reaction method, sometimes called half cell method. Step 1 of the reaction. Find the elements whose oxidation numbers have changed. Choose a substance that acts as an oxidizing agent and one that acts as a reducing agent. Today we are going to see the example of the reaction between Fe2 positive with manganate ion MnO4- reacting in an acidic medium to produce Fe3 positive and Mn2 positive along with some water. First thing to do is write the equation. Identify those elements that are undergoing change in oxidation. Write down the oxidation numbers of the reactants and products. 2 is the oxidation number of iron. 7 is the oxidation number of manganese and manganate ion. 3 is the oxidation number of Fe3 positive. And positive 2 is the oxidation number of Mn2 plus. In order to determine oxidation numbers, you may refer to my earlier video on how to assign oxidation numbers. Whenever there is an increase in oxidation number, the reaction is considered to be oxidation. Fe2 plus changes to 3 plus, so this is an oxidation half reaction. In this case, 1 electron is lost from Fe2 plus to change into Fe3 plus. Manganese manganate ion changes into Mn2 positive. The oxidation number decreased by 5 units, which means it needs to gain electrons, or it is a reduction half reaction, and we are to provide 5 electrons for it. So we have identified the oxidation half reaction and reduction half reaction in this reaction. Fe gets oxidized and Mn gets reduced. Fe2 positive is the reducing agent as it gets oxidized. So all oxidizing agents gets reduced in a redox reaction, which implies MnO4- is the oxidizing agent and it is getting reduced in the process. The next thing to do is normally separate the equations into 2 half reactions. Identify the oxidation half reaction, identify the reduction half reaction. In this case, Fe2 plus changing to 3 plus 1 electron. Reduction half reaction, MnO4- plus hydrogen ions plus 5 electrons giving Mn2 plus. We may also look at the same reaction in a slightly different way, just to get an idea of what's going to happen. In order to do that, we will see what we should be doing. Balance the half reactions. Balance all atoms other than hydrogen and oxygen. Calculate the oxidation numbers on both sides of the equation. Add electrons to whichever side it is necessary to make up the difference and make sure both half reactions have gained equal number of electrons or lost electrons. Balance both sides so that the total charge on the left and right are the same. To balance oxygen atoms, add water molecules on the side deficient in oxygen, and on the side deficient in hydrogen, add H positive ions because the reaction is being balanced in this acidic medium. This is the reduction half reaction, oxidation half reaction. Oxidation half reaction produces 1 electron, and we need 5 electrons in the first equation. Therefore, we multiply the oxidation half reaction by 5 so that we have 5 moles of electrons. Add the 2 reactions, you have a balanced equation. Now, we can take a slightly different look or slightly different approach to the same reaction. We have done this earlier. Identify the oxidation numbers, oxidation half reaction, reduction half reaction. If you multiply the oxidation half reaction by 5, it will produce 5 electrons. The reduction half reaction requires 5 electrons. So we have generated 5 moles of electrons by taking 5 moles of Fe2 plus. Or we have to add a coefficient for Fe2 plus. That's the 5 moles of electrons that we need. If you have 5 moles of Fe2 plus on the reactant side, we also need 5 moles of Fe3 plus on the product side. Since the number of manganese ions on the left and right are same, we're not changing the coefficient since it's 1, it remains the same. Next, we have to balance oxygen. On the left side, we have 4 oxygen atoms in manganate ion. According to the ion electron method, we need to have 4 moles of water on the product side. So we will add 4 moles of water. What remains to be balanced at this time is hydrogen ions. Since we have 8 hydrogen atoms on the right side, we need to have 8 hydrogen ions on the reactant side. So add the required quantity of acid. Now we have a balanced equation. So fundamentally, we have separated the oxidation half reaction, reduction half reaction, and added them up together. And this is very similar to the oxidation method. But when you write it, we tend to separate the two half reactions and write them separately and add them up. If on the reactant side and the product side you have similar elements or compounds, cancel them. The above example, we don't have any such atoms or molecules. Therefore, the equation is actually balanced. So 5 Fe2 plus MnO4 minus plus 8H positive gives you 5 Fe3 plus Mn2 plus 4H2. That's a balanced equation. Since we have hydrogen ions in the reactant side, in the case of the equation, it has to be balanced in the acidic medium. Here are some examples for you. Write down the questions, balance them, and check whether you're getting the right answers. Pause the video to write this. Please subscribe, like, and rate the video. If you have any questions or comments, please do post them. Thank you and have a great day.